Good afternoon, everyone. Thank you for waiting. In the name of the ALADE, IDB, and the Ministry of Industry, Energy, and Mining of Uruguay, we welcome you to this panel called Artificial Intelligence, Digital Transformation of the Energy Sector. Before we begin with the panel, I just wanted to make an announcement. At the end of the panel, we will have some cameramen to get to know some testimonies from you. So we will now have Virginia Snyder, who will be moderating this panel. She's a senior energy specialist at the IDB and will be moderating this session. Thank you. Thank you, Luis. Good afternoon, everyone. We have a great challenge with this panel because after lunch, we have to stay awake. So please, let's try to keep it going. Welcome, everyone. I have an amazing panel here, not just because of the quantity of people, but also because of the experience of everyone here. First of all, I want to name you so that you can associate names with faces. Give me a second. We have Carlos Von from Hawaii, who is specialist in solutions. We have Donato da Silva Filho from Bot Robotics, who works with electrical energy, data science, and AI. We have Alejandra Reyes from the National Direction of Energy of the Ministry of Energy and Mining of Uruguay. We have Oliverio Alvarez from Deloitte of Spain. We have Constanza Levican from Suncast, Chile, and we have Marcelo Alvarez from Energía and also from the Chamber of Renewable Energies of Argentina. Welcome, everyone. So, to put the panel into context, I want to tell you a bit about how we are working on the topic at the IDB. So we have a short presentation to tell you a bit about what we're doing, and then we will continue with Oliverio, who is going to present a work that we have just finished together. So first of all, as you all know, in a world where we have to electrify economies more and more, and we need more renewables incorporated into our electric systems, obviously, digital transformation and artificial intelligence are allies that are fundamental for the energy sector. In this sense, to give you some figures, the International Agency of Energy, in one of its studies, got a figure that is quite impressive. So 80 billion can be contributed to the energy sector at a worldwide level. And that has multiple benefits. Here we divided it into three big subjects. Of course, for the users, which is the great new player that for years in the energy sector was not taken into consideration as a key player. They have a very special role nowadays. Now with digital technologies, we can do many things to improve consumption, to have the use of different applications, use of blockchain and AI. Then we have flexibility. So greater technology and more digitalization gives us more flexibility for the electric system, more incorporation of renewables, and these variables require a better management of our system and to be able to respond to those changes in the system. And lastly, the third triangle is resilience. In a world where we see natural disasters that are more and more frequent and stronger, and we have more and more cyber attacks, having a resilient electric system is really important. And digital tools and this transformation is going to help us make our electrical systems be more resilient to that. So from the bank, and of course in many of your countries and organizations, regulators here present today, we understand that creating the necessary policies and frameworks for the digital transformation to move forward and to accompany In general, technology goes faster than the regulatory framework. So in the bank, what we're doing is supporting the countries in following these quick steps of technology so that technology is not blocked by frameworks that are not up to date or are old. So we are working with Chile and its regulatory framework, also with Panama in a sector strategy. In Panama, we are also supporting them with their strategy for digitalization, also in Trinidad and Tobago and others. So these are just some examples. You probably have more examples, not just of countries and organizations, but also of how companies are creating their plans, etc. So some of the things that I also want to talk about for those who are perhaps working with the government and public institutions, some of the tools that we have developed and are available for free for those who want to use them. Actually, we need more users in order to improve these tools. We developed, and I was lucky enough to participate some years ago in the development of Energized, which helps us detect fraud or energy stealing. We are also using drones prior to the development of projects for the environmental and social aspects in order to supervise different populations and areas, and also in order to see how the works are going. Of course, they can be used for lots of other things, such as supervising different lines. Then we also have satellite images. We're working a lot with that. And blockchain technology in an application that we are also supporting one of the countries with. So apart from what we talked about, so regulatory framework policies, development of pilots and applications, we also have investments in infrastructure. I'm going to show you some examples. I'm not going to talk about each of them, but we're doing this at the bank. And we're doing this because we are convinced that the energy sector is going to need this. And so all our investment loans have to be 100% aligned to the energy sector in these things. That's why it has to include actions that help the different countries move forward on the topic. And lastly, last but not least, we feel like the region is a bit behind. There's a lot to do, a lot to move forward with. The more we digitalize and the more we join assets, systems, the more risk we have, and we have to prepare more. So in that sense, we are providing training for technicians, CEOs on the topic. We have also developed self-assessment tools with experts on the subject matter, and it's available, anyone can use it. And last, we have developed together with Deloitte, and Iberia going to talk to us about this now, and you have the QR there in case you want to download it. Obviously, the countries of the region have moved forward on the topic in a very heterogeneous way because they are very different. But this roadmap for the digital transformation of the energy sector has a series of lessons learned. We look at countries that are more advanced in the sector. We have a lot of lessons learned, and we show recommendations that we hope are of interest and of use for you. So now we will have Oliveira. Thank you very much, Virginia. And first of all, I would like to thank you for the opportunity of sharing this dialogue space with all of you. Virginia has really outlined the grounds that we have in the terrain of digitalization. So what do we want to do with this roadmap? So basically three things. We wanted to analyze what was the situation that we observed in some jurisdictions that we thought were interesting in order to learn from their mistakes and from things that they did right. Then we also wanted to have the opinion of the agents of the region. More than 50 agents have participated in the works, in the study, and we wanted to understand what were the main issues and the main messages that were conveyed. I will start with the vision of the agent. So we developed the service between July and September of 2023. So we're talking about something that is quite recent. What are the first conclusions? Firstly, what the agents told us is that we were starting with a situation where digitalization was not deployed. Around 40% of the ones who were surveyed said that they were in very initial stages of the process of digitalization. Only 8% said that they understood that they were already moving forward. And so a first message is that there are opportunities for digitalization in the region. A second important message: the degree is heterogeneous between the public and private stakeholders. And so, for example, in the public sector, only 3% of those who were surveyed identify their organizations as organizations where there is status that is advanced in adoption. In private, we have the private sector. We have around 19%. If we talk about the states that are most delayed, we see that, for example, the public sector has up to 41% of the stakeholders saying that we are still in a stage of creating awareness about the situation, and 19% for the private sector. So a first conclusion of the study is that perhaps the region is not really moving forward very fast in this sense. As Virginia explained, of course, there are different situations. Why? Because we identify a set of obstacles. There are three that are fundamental. First, the cost and the level of investment that is required. This is a key point. We identify that digitalization has a cost that some agents can't yet assume. And then we have the capability of development and implementation. And here we have two things. So even if there is intention to digitalize, maybe there's not enough infrastructure, the complementary infrastructure that is needed. And so we're talking there about communications, even the organization itself, or the situation of the clients. And there's also not enough of a digital culture. And the third element, and it's especially interesting, I want to highlight it, is regulation. If we take a look at the results, we see that inadequate regulations are also an obstacle, but this appears as the second thing that is most important in the private sector, but it's second to last in the public sector. And so it's interesting that these elements, the costs and that need for infrastructure and digital culture, are shared, but if we take a look at regulations, the private sector identifies it as an important challenge and the public sector doesn't give it as much importance. So what other things does the survey tell us? In the report that Virginia was telling you about, you have all the details. We see that digitalization in the region is a digitalization that increases. So it tries to make processes more efficient. It tries to accelerate the deadlines, but it's not disrupted. This is important. It's also a digitalization that appears in three main blocks. It affects the assets, it affects the relationship with the workforce, the talent that is both internal and external. It's very important what we saw in the pandemic with working from home. That's also digitalization. And it affects the relationship with clients and groups of interest. It's not just that a client can access data for consumption. It's also about contacting the utility, the distributor, the energy company in order to know what is the status of a certain request, a request of access, or a complaint, or any other element. So from then on, we identify up to 12 best practices and lessons learned according to the stakeholders of the sector, and then we will talk a bit about the international area. So that framework, the need as well of having an infrastructure that is adequate in order to develop these programs, very related to the framework is the development of pilots, of sandboxes, of programs of learning as a key element. We also identify things related to the digital culture, as I said before, that need of having identifiers, KPIs, different indicators that constitute a common language within the region. Also, the need of accelerators of this whole process, the need for resilience and cybersecurity, the need to have a qualified workforce. And as I was telling you, we have 12 different things, and another one is promoting the interconnection of the installations, also promoting the participation of consumer, promoting synergy between sectors and stakeholders, supporting the development of regional plans, and to guarantee sustainability during the process. So we're going a bit slow, but then you will see all the 12.
Thank you very much. And now I want to ask Alejandra, you have some work, some very important work for Uruguay, and you work a lot with data. Tell us about the experience from converting those analog data to digitalizing them. Very well. Good afternoon, everybody. It's wonderful to be here. Thank you for the invitation. I work in statistics, planning, and balance of the National Directorate of Energy. One of the main products is the energy balance of the national energy balance, and for that we need a very interesting amount of data flow, the different ways that we can imagine to get data. And this process for us is very important. Perhaps it's not disruptive, but it is necessary because Uruguay is very strong in data, which is the most costly thing to have. So we have to go through this path in order to strengthen our product. We are part of this national statistical system. That means that when we publish a data, national data of the energy sector, we are obliged to disseminate this data. So if we don't have the tools and the equipment to do this, then we collect data. It takes a lot of work, but we can't disseminate it because we don't have the tools or because it's very expensive to disseminate this. And we started in 2018, 2019, looking for resources, economic resources, because from the state, investing on data is not always seen as a necessary investment. So having technical teams, very qualified teams to be up to date with new technologies, when what we do is the baseline, if we don't have the data, it's very difficult to build what comes after. So for us, our team, we have between 7 and 8 people in the team in planning, statistics, and balance. We are very committed. The team is always trying to have new opportunities. And with that team, we came to the bank, who gave us the first drive to have an inventory of the data that we had and to see how we could start this process, how we could start organizing ourselves. And the team does have organizational structures, which are very important regarding what data we have, what's the trajectory. We are now celebrating the 50th year of OLADE, and the first energy balance of Uruguay was from 1965, and it's been uninterrupted until today. So you can imagine how much data we have, because once it's in the energy balance, it becomes data, and we have to keep this published, and we give access to all. And going back to the support, how did we start in this process? We started making this inventory of data and trying to define all, we have the presentation, but anyhow, could we show the presentation on the screen, please? That was the starting point, and that guided us to building an architecture. So we went through different tests. They weren't all right, but some of them this is part of the architecture that we tried out to start working with different databases. But the input was to have we were trying to have all the data that we had regularly and to design that architecture that you saw in the previous slide. And after a lot of going backwards and forwards, we came up with this. Lastly, what I wanted to say is that with different technology like OLAV, we wanted to disseminate the data. We wanted to make it accessible and allow the final user to make other uses of the information that we published. The balance was our first data. It was a matrix. We have the sources in the different columns and the activities in the lines. And we have 58 years of information. So every time we publish a product of the energy balance, we do this manually. We take the data from the matrix, then we put it in the report so people can see this. To have this energy balance with a database, and this is the first player I'm going to name now. As I said, it's very difficult to advance in the state with this, but we have the university, the academy in general. When we had our database organized, knowing where we wanted to go, we started presenting ourselves to different projects with different alternatives. The energy balance was one of them. There was a group of students who developed a database of the energy balance. Then we internalized that to make that a real product for the area. So having that energy balance on a database allowed us to develop visualizers, because we did the balance and then we gave the public to do their own reports after that, so they can cross the information. And then we have a third player there, which is very relevant, which is AGESIC, which is a government agency. AGESIC is the government agency for the development of technologies. It's about data. It's all about data. Open data. They have the governance of this. So AGESIC helped us to develop visualizers, because AGESIC had, for public sectors who had previous development. So when we had this energy balance on a database, we were able to work with them on that visualizer. While you have the mic, I want to ask you a question. Regarding artificial intelligence, what are you doing with this? Well, we follow along the same lines. We're knocking on doors. Here we have people who have worked on these projects. And when we see opportunities, this was also done together with AGESIC. They hired experts from Argentina in that case. we were the winners of this project, so we developed artificial intelligence for this. So we need to have a very advanced level of digitalization for this. And we had the acknowledgement of panels and solar collectors through imaging. Through units, we started identifying. We have some images at the end of my presentation. We can keep improving. The municipality of Montevideo has published a new set of data in the area. We want to keep improving this. I hope you understand the problems that we face. Regarding statistics, being able to collect the amount of solar collectors that we have in our country, it's impossible. Because of their development, the statistical error that we can get through a survey is unfeasible. So the best way to do this was with INAC. As I said before, one of the strengths of Uruguay is data. So we had a whole lot of images of the whole country. It was done in 2017, and that was used to advance and at least have a sample of this. Now, regarding digitalization, we do have other products and domino effect to have started at that time. So we today are in a digitalization process of INGLES. That's another product. It's a greenhouse gases inventory. And why is this so important? Well, Uruguay not long ago announced our VIX, our first security bond index to greenhouse gases, and we have those commitments, and we need to have an audited system, a system that can be audited in order to see if we are advancing in the process. We can do that because we have the database. We also developed other visualizers that on a monthly basis we have available. This was done with an IDB project. We have disaggregated information because the load of this data has been automated. Before it came through email, through a survey, but now it goes to the cloud of MIEM. And the database of ANCAP, for example, I see representatives here, are uploaded directly to the cloud of MIEM. It's not done by email anymore. So UTE's data goes to our cloud and it's uploaded to our database automatically. And that allows us to develop other products and make other analysis. So those resources that we were using to collect data, now we are using them to do other products. Maybe not so disruptive, but they are needed. And they have to be made available to the population with the data. That's why we are working. We want society to have more access to the data so they can question us, they can use the data. We didn't have the tools to make this available before. Last month, we closed a project with the School of Engineering where we predicted the demand in the short term of electricity, leaving the econometric models. And there we analyzed, looking as an input, not only the information of the residential, but we know that it's more complex when we want to make a projection. Remember that Uruguay, its main sector for electricity is the households. So being able to forecast the demand of households is half of the problem solved. So we worked with the other methodologies, which historically was done with econometrical models, but now with the new methodologies, we worked in sensal areas where we collect all the data and all the characteristics of the households, the socioeconomic characteristics of the households, and that contributed to developing these models, and we analyzed the impact of temperature, but even more the characteristics of the household. So the efficiency team that is here today showed us all these subproducts that we have to start working on digitalization. Thank you very much. That's a very important topic. And now we can look at another whole panel, which is data and how that data that we collect, how much energy do we need to collect and save and store that data? Okay, let's go on to Constanza. She works a lot on artificial intelligence. So please tell us, what's the role of the forecast of renewable energy for the electric systems? Let's see if your presentation can be put up on the screen. We have 2 chairs available here for the people at the back.
Muchas gracias.
Excellent. Thank you very much for the invitation. I come in representation of Chile and the technological innovation. I am founder of this business that it calls Suncast, and which is a digital native, but also of artificial intelligence, also a native in artificial intelligence. When we started 5 years ago, we applied artificial intelligence for renewable energy, wind and solar, since always. So we weren't a software company that suddenly found this since we were created. So in order to explain what we do step by step, we were just talking about the energy balance, which is a product that takes the data of production and consumption every whole year, or I don't know, it can be quarterly, but in general it's yearly, and it says who consumed and who produced that energy. The thing is that we saw this need, but in real operation, because one thing is the planning, long-term planning, and another thing is real operation. So what happens in countries where we have an increase of renewable energy? We need to apply more intelligence, because solar and wind power vary with meteorological conditions. And so if you have a solar plant, you can work with it, but when there's more than 200, like the case of Chile, between solar and wind farms, what happens if tomorrow it's cloudy? What happens if the day after tomorrow in a sector, in a whole region, there's not as much wind? So all of that starts to affect the energy mix. And that uncertainty is something that has to be handled with artificial intelligence. It's not just saying how much is being generated by a plant in real time. It's important to predict in order to know how it's going to behave. So that's what we do. We have 2 sources of information. The first one is forecast, weather forecast, satellite forecast of the place where the plants are at. And the second one is the data of real production of the farms. And so all this data is taken from historical data. We train the prediction models, and we have that training. So this consists of more than 20 weather variables apart from the real production, for now of a year or as many years as the plant has been active. So with that, we have to eliminate a lot of information, because there's constant failures in operation, or there are limitations due to an excess of energy at times. And so sometimes farms are producing less, not because there is not as much wind, but because the operator of the system is limiting them. And so we get all that information that is not yet ordered and organized, and so we have to check it and see if there's an external factor that causes it to produce less. And so when we have cleaned the database, we can apply it to our neural networks, where we train a predictive model for each plant. And so with that model and the way in which AI works, it learns with thousands of examples from the past how the solar or wind farm reacts according to the weather conditions. And the third point is that this is created as a package with a forecast. So this is a file that is sent from server to server. In the case of wind in Chile, it's sent in an hourly basis. In the case of sun, it's 3 times a day. And so it's a file that says how much is going to be generated by the park in the next 24 hours. And that information is used by the National Center of Dispatch of each country. Well, in the case of Chile, it's used by the National Electrical Coordinator in order to plan the day after. And so this ISO, or system operator, is different in each country. Each country has, I put it here at the end because they're the ones that get the forecasts and program the dispatch. Each of them has a frequency. For example, you have to send it hourly or once a week, or there's many different situations. Some countries it's sent once a week, then once a day, and then intraday. It depends on the dispatch system that they have. If they have a dispatch for the day after, if it's intraday, etc. That's the regulation that is required for wind and solar plants. So then there's a time frame for the next 24 hours, 48 hours, 10 days, and there is a granularity, which is another difference that is different in each country. In the Chilean market, it works in an hourly way. The prices are hourly. There is a price at 11 a.m. for each node. There is a price at 12 and another one at 1 p.m. And there's other markets that are working every 15 minutes. So the dynamic is much faster and the prices are also changing faster. And it's important here to really have a leap in artificial intelligence. Up until now, there were fewer centrals and they weren't variable. In a thermal central, I know how much I'm going to get when I turn it on. But if we want to take that leap and have a mix that is 100% renewable for 2030 or 2050, according to each one, it's necessary to incorporate that, because here I put a small graph at the right of a real wind plant of 40 megawatts, which on November 12 generated nothing, but not because of limitation or failure, but because there was no wind at all. And on November 12, we jump to November 18, where in the morning there was low generation, but at night it was working at full speed. So what happens? Before, there was the thing of saying these energies are variables, they vary, so let's not use them. But that doesn't help us with reducing the contamination of the planet and using these energies that are more attractive economically than others. So that type of thing of planning for the next day and seeing how energy is going to increase or diminish and have automatic programs that are going to incorporate all this information is very important. In the next slide, we can see, because we've had to study this and understand it in depth, we are a Chilean company. We offer our services. We were born 5 years ago. We started 5 years ago, and we offer this in Chile for wind and solar plants. And we are running pilot projects in other countries, and so we are eager to learn from other countries, other regulators, how it works over there. We have a pilot project in Mexico, Colombia, but we have realized that we have this need for a leap, because once we can have that, and that leap, talking about something Virginia said, it comes with regulation. So in AI and energy, regulations generate a more modern electrical market and more opportunities for business, new ways of participating of the wholesale market, and that's when you can apply it. And the last point, I want to tell you briefly about a conversation that is being generated in Chile through the regulator, which is the Commission of Energy, where they have already created a preliminary study, but now they ended with a tender of a in-depth study to go from a cost market to a offer, to a supply market. And so this is a very in-depth study where they need to monitor the market, and they are recommending to increase the temporal granularity so the market works every 1 hour and there is a dispatch the following day. So to have more dispatches in 1 day, or maybe for it to work instead of every 60 minutes, every 15 minutes. And so within the tender, it is requested to have a view of at least 4 countries. So Chile is also looking at what the rest are doing, its neighbors, to see what is going to be the market of the future. Thank you. How's it going? Okay, and Constanza mentioned something that is super important, which I want Donato to tell us about. In terms of prices, how do we decide in that planning and forecast what are the important variables in order to determine price? Thank you very much. Thank you very much for the invitation, the opportunity. I think that it's better that I talk in English rather than a mix of Portuguese and Spanish, but however you feel comfortable. Creo que mi presentación es otra. Me gustaría mostrarles un modelo que desarrollamos para una planta en Río, en Brasil. Se puede aplicar a otras fuentes de electricidad, pero les voy a hablar de una aplicación. ¿Podemos pasar a la siguiente? Un momento, por favor. Entonces, cada vez que hablamos de inteligencia artificial para ayudarnos con algo, normalmente pensamos en un robot que nos va a guiar. Esa es la imagen de aquí. I don't know if someone needs a device to hear the interpretation. Cuando empezamos el proyecto, teníamos que predecir los precios en el mercado, la tendencia del precio de la electricidad en el mercado, y teníamos que decidir si es que la planta hidroeléctrica iba a tener que comprar o no electricidad en el mercado. Entonces, era una gestión de riesgo en tiempo real. Y cuando empezamos a hablar de esto, se pensaba, bueno, ahora los robots van a hacer todo por nosotros. Y va a ser algo así como otro empleado, alguien que va a hacer el trabajo. Y luego nos dimos cuenta de que probablemente teníamos eso en mente debido a nuestra infancia. Y si pasamos a la siguiente diapositiva, pensábamos que era algo así, con lo de I'll be back. Y el primer desafío era cultural, había que hacer que la gente cambiara de opinión y realmente lleva tiempo. Era solo eso. Y ese era el desafío. Educar a la gente, implementar la inteligencia artificial y desarrollar las capacidades de datos. Y por supuesto había preguntas para ver la cuestión de la madurez de datos que había en las empresas. La cuestión es cómo es que se beneficia tu trabajo por la calidad de los datos. Muchas veces no hay una gestión de datos muy profunda en la cultura. Entonces, cuando hablamos de inteligencia artificial, estamos hablando de una máquina que puede aprender de los datos y puede tomar decisiones, incluso cuando los datos son completamente nuevos, cuando es una situación nueva. Es una situación nueva, entonces algo a lo que nunca se había visto expuesto. Empezamos a trabajar con esto, entonces está el desafío de tener los datos del pasado, ver qué es lo que va a influenciar el precio, entrenar a los modelos, predecir los datos y predecir el rango, y también el rango de las reservas, y juntar todo eso y ver todos los contratos que tenía la planta, las obligaciones a futuro, y luego optimizarlo y ver si es que había que comprar o vender electricidad. Normalmente este proceso en las empresas uno ve a 18 meses, se pasa simplemente un mes entero juntando los datos y validando los resultados. Entonces ahora se puede hacer todo automáticamente. ¿Qué es lo que hacemos? Si pasamos a la siguiente diapositiva. Está la planta hidroeléctrica, está el desafío de predecir el flujo de agua y también el desafío de ver el mercado y ver los precios. Creo que podemos pasar a la siguiente. Entonces, uno de los desafíos es que la planta tiene que vender la energía a futuro, pero no sabe si va a poder producir o no. Entonces tiene que ir al mercado, o si es que hay un exceso, puede vender el exceso en el mercado antes de que el mercado vea ese exceso. Cuando el mercado ve el exceso, los precios bajan. Cuando el mercado ve que hay una falta, los precios suben. Si la planta puede ver eso antes que el mercado, puede tomar acción, pueden comprar, vender y se puede reducir la exposición a los precios altos o bajos dependiendo de la situación. Ese era el punto principal. Y lo que hicimos, si pasamos a la siguiente diapositiva, es que desarrollamos lo que se llama un equipo robot. Este proyecto se desarrolló por Volt con una empresa para una empresa que produce energía eólica, solar, y se financió por un programa de investigación. ¿Y por qué tenemos diferentes tipos de robots en la pantalla? Si pasamos a la siguiente, vemos que hay 6 robots diferentes. Y pasamos a la siguiente ahora. El primero recopila la información de diferentes fuentes, el precio de mercado, el flujo de agua, los mapas meteorológicos, y todos esos datos se ponen en una base de datos. Esa base de datos le decimos amarilla, decimos que no está listo aún para usarse. El segundo robot viene y aplica un montón de reglas a esos datos para ver si es que son válidos. Si los datos están validados, entonces se transfieren a una base de datos verde. O sea, ahí si es que vemos una bandera roja, sabemos que hay un problema. O sea, eso no, nosotros tenemos que ir ayudando también al robot a ver cómo hacer las cosas. Y luego hay un tercer tipo de robot que entrena y valida los modelos de pronóstico para diferentes cosas, para el precio de energía, para la producción, y tienen todos los datos de diferentes fuentes. Y luego el cuarto tipo de robot aplica los modelos de pronóstico y con todo listo, estos pronósticos, todo está pronto para tomar las decisiones. Entonces operamos este modelo de optimización que decide si se hay que vender o comprar electricidad para lograr este equilibrio entre riesgo y valor generado. Entonces está por un lado el riesgo y por otro lado el promedio. Y hay un robot que trata todos los resultados, los guarda en una base de datos y entonces se puede mostrar los resultados a los usuarios.
Acá tenemos diferentes fuentes de datos. Se pueden ingresar 7 u 8 veces. Tenemos diferentes fuentes. Acá tenemos las reservas, el precio de mercado, que es BBC. Es donde las personas compran y venden. Y luego recabamos todos los datos, lo ingresamos a la base de datos. Y acá ven que tenemos 31 megabytes por día y este es el proyecto. El robot trabaja todos los días. Acá tenemos 20 gigabytes de datos en la base de datos y utilizamos los datos para tomar la decisión y luego los datos quedan ahí. Los podemos seguir utilizando entonces para hacer otro modelo. Acá tenemos 7 pasos para decir que un dato está pronto para uso. Tenemos que primero encontrar las fuentes de datos y luego ver dónde tenemos que especificar los datos. Qué tipo de datos, el valor esperado, etcétera. Luego que recabamos los datos, tenemos que tener un momento en el tiempo para estos datos. Luego tenemos las primeras pruebas, las pruebas de formato. Debería ser una palabra, pero es un número. Luego pruebas de consistencia. El valor es en un rango que sea consistente con los valores. Y luego pruebas relacionales. Una vez que aumenta el valor, el otro baja el valor, ¿esto está pasando sí o no? Acá hay un error. Y luego vamos y decimos, bueno, están prontos los datos para utilizarlos. Y esto lo hacemos para todos los datos que recabamos. Es mucho trabajo. El segundo grupo de robots, tenemos 900 robots, porque hacen diferentes tipos de pruebas con los datos. Acá tenemos el modelo. Hay un robot que no les mostré, que es el orquestador. Y aquí está recabando los datos, está validando los datos y va a hacer correr este modelo y nos va a poner todos los resultados en la base de datos. Y va a llevar 18 minutos. 18 minutos. Pero yo voy a acelerar el video para que tarde solo 1 minuto. Acá tenemos nuestro colega Marcos, que está en el proyecto de desarrollo. Acá se hizo correr la prueba. Ahora vamos a ver los resultados. Se salvó, se guardaron los datos. Ahora podemos ver los resultados. Esto es un caso real. Fue uno de los primeros casos que terminamos con validando los datos. Acá podemos ver los resultados, arriba a la derecha, los resultados esperados y los resultados en el peor caso, el peor escenario. Y el valor esperado de la cartera fue aumentado en 165 millones de reales. Es la primera vez que se hizo correr el programa, así que fue muy bueno, muy interesante hacer correr esto. Y acá les muestro los principales resultados. Lo que les acabo de decir, 165 mil millones de reales. Este proceso se hacía una vez al mes, pero ahora lo podemos hacer todos los días. Así que fue una gran mejora en la gestión de riesgos. También obtenemos el precio del mercado. Cuando vemos que el precio sube o cuando baja, podemos corroborar que es correcto. También tenemos un cambio cultural con la inteligencia artificial y tenemos reuniones semanales. Todas las semanas hablamos con las personas, les decimos que no hay magia, que hay que trabajarlo. Y toda esta ciencia de datos es muy difícil, es mucho trabajo, pero tenemos las ganancias que resultan de la productividad y ahora tenemos un resultado mucho más estable, el riesgo es más bajo. Entonces realmente tenemos una ganancia en cuanto a la productividad. Esa fue la última diapositiva. Si quieren más información, tenemos 3 publicaciones. Una fue de Brasil, La segunda fue aquí, en Montevideo. Esto es el proceso de aprendizaje por máquina. Y la tercera fue en Australia. Fue un modelo de proyección de precios, que fue el pasado junio. Como acá tenemos a la gente del equipo presentando estos papers. Y eso es todo. Si ustedes quieren, estos papers nos pueden mandar un mail ahí donde tienen en la pantalla y se los pasamos. Thank you very much. That was wonderful. Thank you for giving us such important information. And you have 2 cases in the region which are very interesting. We have 2 more panelists. And I also want to let's start with Marcelo. We have a presentation. We are a little bit behind with our schedule, so we will have to go a little bit quicker. Okay, I'll be brief. This is an expert panel on digitalization and myself. You might say it's nothing new to have and what we can't do with gas, and not the other way around. And not because a country like Argentina, which is not an Annex 1 Kyoto Protocol country, that has in relative terms low commitments to reducing emissions, but because it's cheaper. Let's stop discussing if it's cheaper or not. We just have to see how we can do it more efficient. So we have to focus on digitalization to do this faster. The main 2 obstacles in Argentina are access to financing in repayment terms, and digitalization is the third one. And for high penetration of renewables, we need to digitalize the matrix, but in Argentina we can move even faster. This is the DUX curve, or the demand curve. I couldn't realize at first why this was a duck, but now I see that we have to work on this to try to have a more reasonable distribution. These are demand managers. They say we have to set the duck off and make it fly. And for this, we need to manage this, and we must digitalize this. The problem we have to solve in the renewable sector and in the energy sector in general is how we manage energy, the model that we have today was designed for sources that are not variable, and they had a reserve of potential. And now we're trying to put technologies all together, but they're different. And we can try, if we continue trying to do this, we're going to get the same result. Latin America can be integrated in the power grid. We have 6 different time zones, and we can exchange electricity between countries. This is a challenge to do things cheaper and in a more intelligent manner. I want to share with you something that I think reflects the time that we are living today. It's from Tarquino. He was the king of Rome before the empire. That was around 560 before Christ. And the legend says that Tarquino sees an old lady who has 9 papyrs, and the old lady says, these are the 9 papyrs of universal knowledge. Do you want to buy them for gold? And Tarquino laughs at her. He doesn't want to do this. So the lady burns out 3 of these papyrs. And the lady says, I can do whatever I want with them. Do you want to buy the 6 that I have left for gold? And he says, no. The old lady burns 3 more. So there are only 3 left. She offers to sell them again to him. And Tarquino was thinking, I might be losing something very important. And in the end, the legend says that he buys those last 3, and those documents become the oracles of the Roman Empire. This is a legend, but I want to tell you that because Aquino did not know about this, he had no knowledge on this, he bought the same documents for the 3 times the price that he could have bought at first. And the study I showed you was to share that renewables are not only cheaper, but it brings out, it creates more jobs and it lowers emissions. So we have to do it at least because it's cheaper. Thank you.
I want to have Carlos speak now to tell us a bit about digital transformation and AI. Thank you. It's a pleasure. Thank you for inviting me to this wonderful talk. We've obtained lots of information. And just to complete a bit of the information, because I think that most of the things that I wanted to talk about have already been touched on, but I also wanted to mention that AI and digitalization is also something that is more specific to the teams. We know that AI, learning, predictions are done with generation and consumption. But what happens with granularity within these teams? But that's why we want to talk a bit about the vision that we have of how the new energy system is going to evolve. And as can be expected, it's going to be a full change, perhaps not just one time. It's going to be progressive. And it's necessary to have intercommunication between all these systems. We need for those elements to, whether it's the generator, the industries, to have their own capability of integrating and communicating between them, and to try to find the balance in this energy system. For that, it's necessary to have 2 things. One is an improvement in the electronic elements, so power electronics, and then the other thing is based on algorithms, so clouds, AI, etc., etc. So we have this idea, in this case we are providers of products, but we also want to delve into this world of AI. We want to optimize, we want to generate and produce. And we see that AI is going to start with the beginning of a plant up to the operation. So all of those processes can have AI implemented, and we can optimize them, even if it's a little, whether it's production or efficiency. So we see some figures, and thanks to different elements that we've used throughout this value chain, how we can improve up to 10% when we talk about generation efficiency of the equipment, 20 times more speed or easiness of operating it or maintenance, and there's also 1% more with operations. The important thing here is that it is a process where any sort of equipment can come into play, or any type of process. We put as an example our AI Boost, which is an AI system that helps us detect failures, and our equipment are photovoltaic inverters. They are the heart of that, as we say, and they're very important for safety. So here we begin to talk about something that is fundamental of this whole chain of processes, which is safety. We want the equipment not to fail, and if they fail, that they don't affect people or the rest of what surrounds them. So the 4 fundamental steps, so learning, the updating, with having this learning about the equipment or whatever, and then action. Action is going to give us a result, and the result, we have to see if it's precise, or if it's good. That's going to give us data. So what's fundamental is data here. And with that, we will continue in a cycle and continue to improve our model. We will continue to train our models with more data, and that's what we want to do with our equipment. We have equipment around the world, a network, and the idea is for these failures and things that happen to be able to feed the system so that it's more and more precise when detecting those failures. In this case, an arc failure. And another example, a very interesting point that we talked about today was granularity, and we think that it is also one of the trends of the industry. So just as an example, we see inverters. We see that some years ago we had central inverters that were in charge of a whole plant, photovoltaic plant. Nowadays we have different types. We have chain inverters or microinverters, and we think that that trend is going to carry us forward because we want data that is as specific as possible. So if that's the only module, even better. So if we have thousands of data, but the model that we have, we can control that and we can manage that in a better way. So here we have different technologies that we try to measure. We try to see how each of those modules, solar modules work. We also work with batteries, with storage, and we try to see what the process of energy is, and also the loading and unloading. Knowing about these curves, knowing about the parameters, we can know what could fail in the future. And so we start to work with prediction, which is a very interesting topic. Currently, we have not gotten to prediction yet, but we want in the future to be able to avoid issues. We see catastrophic failures, specifically in storage, perhaps when there is a fire, for example. It's a system that is a fire that is almost impossible to stop. And so the idea is to be able to have active protection, and if there is a fire, of course, to be able to stop it. But we also want passive protection in order to know that a system could fail in the future. So we have to take a look at the normal behavior in a system so that we can see how to stop any possible failures. And also when we talk about optimizing different scenarios, we have the optimization of solar modules. Each of these tables has its own tracker. And nowadays, with the technology that is available, with algorithms of AI, we can measure the angle that each has to have in order for them to be as efficient as possible. We can see it in that diagram, how before all the modules followed a same angle, and so there were some issues, and there was a lower efficiency of generation. And what I was telling you at the beginning, these small details, these small changes, or places where we can apply AI, can improve the generation, what each of those plants can generate. Here we have some examples, up to 1.5% of generation for using this sort of solar energy. And so the idea is to try to improve the follow-up, the inverters, the transformation system, and so we will be able to have a much more efficient system, and also we will have a system that is interconnected. Can you play the video? Well, anyhow, the idea here is to try to see how those equipment, how that whole ecosystem works all together, and can therefore improve things, because we have constant communications between all of them. So the transformer with the inverter, the modules, they provide feedback to the equipment. And so we see that this is going to improve the system. We see that in this example. How the system helps us have better sales of energy, up to 35 cents per watt. And here, just to summarize this success case, and just not to continue repeating myself, so if I can go to the next slide, we see that as part of the vision of Huawei Fusion Solar, artificial intelligence is going to continue and is going to be one of the main things in our industry. As Constanza was saying, AI for forecasting demand and generation is going to be fundamental in the industry. And also, when talking about equipment, we can use artificial intelligence for forecasts or studying the life cycle of our equipment. We can know from the beginning how long they're going to last, when we're going to have to replace them, and the recycling process of the equipment, so we can plan their life cycle. And just to finish, integration. Integration is very important when we talk about the systems. They're not going to change at the same time. We're going to have progressive change, and so there's going to be a lack of balance in the system. And so it's very important for artificial intelligence to enable us to see when is the right moment, or what is the right capability that we can have in our system. Thank you very much, Carlos. I want to ask Oliveira to summarize this, because a lot of the things in the publication have to do with these topics, so we would close with that. Yes, of course, Virginia. I think that the most relevant thing is in the publication we have cases of outside the region, fantastic cases in the region. I think that there are several ideas that are key. Digitalization is a process. It's not something that you digitalize and it's over with. It is a continuous process. It doesn't have an end, and it is a process where technologies continue to live together. We can't overestimate the benefits. That's also an important thing. We said that costs, digital culture, all of that are issues sometimes, and so we have to evaluate the benefits and also be aware of the difficulties and costs. And we need to divide the benefits adequately. Oftentimes, the people who have to bear the cost don't receive the benefits, and so there are dynamics that make digitalization difficult. Digitalization, so we have we have a client, a source of interest, a source of work, and an asset. And so we have sensors and acting people, and then we have communications and calculation, treatment, processing of information. We've heard about fantastic cases of how to do that. And we are going to have 4 drivers that are going to help digitalize, and so the client, planning, managing data, renewables, how I estimate the production, how I give a new role to the DCO, how I make pilots, resilience, both physical and cyber resilience, how I minimize when there is an issue and how I respond. And if we do all of this right, then we're going to generate value chains in hardware and software that are going to be very positive for the region. That's it. Thank you very much. It's great to have this amazing panel. We've heard from the public sector and private sector. Thank you, all of you, for being with us. We went a bit over time. Thank you. A round of applause for them.
Terminó.